Ship of Theseus. What makes something itself? Picture a grand wooden ship built for the hero Theseus, anchored in Athens harbor. Over the years, every plank, mast, and beam rots and is replaced. Centuries later, not a single original part remains. Is it still the same ship? Now imagine someone has secretly kept all the discarded old planks and rebuilt them into a second ship, which is truly the ship of Theseus, the one that's changed slowly, or the one built from the old parts, or could both be the same ship in different ways. This ancient puzzle asks what makes something the same over time. Its materials, its form, or the story we tell about it. It comes up in surprising places today, from restoring historic buildings, to replacing body parts and even in digital identity online. Schrödinger's cat, alive and dead at once. Now step into the weird world of quantum physics. Imagine a closed box containing a live cat, a radioactive atom, and a device that releases poison if the atom decays. According to quantum rules, until we look inside, the atom is both decayed and not decayed. So bizarrely, the cat is both alive and dead at the same time. Physicist Erwin Schrödinger came up with this idea in the 1930s to show how strange quantum superposition becomes when applied to everyday life. Once someone observes the box, the cat's state collapses into either alive or dead. The thought experiment forces us to ask, does reality exist in a definite state before we observe it? Or do we in some sense help create reality by looking? Even now it sparks debates about parallel worlds, consciousness, and the limits of scientific observation. Brain in a vat, what if everything is fake? Imagine your brain has been removed from your body, placed in a jar of life-sustaining fluid, and connected to a supercomputer. The computer sends electrical signals to the brain that perfectly copy your real-world experiences. To you, life feels exactly the same. You see the sky, feel the wind, taste food, but none of it is real. It's all electrical signals. This is the modern version of an older idea by philosopher Descartes, who imagined an evil demon tricking our senses. The brain in a vat asks, if all we know comes through senses that could be faked, how can we ever be sure what's real? It doesn't prove we live in a simulation, but it does show that certainty about the outside world is harder than we think. The trolley problem, sacrificing one to save many. A runaway trolley is speeding down a track toward 5 people tied up ahead. You're standing beside a lever. If you pull it, the trolley switches tracks, where it would hit just one person. Would you pull the lever? Most people say yes. But what if instead of pulling a lever, you'd have to push someone onto the track to stop the trolley? Suddenly many hesitate. This puzzle reveals the tension between 2 ways of thinking about ethics. One is utilitarianism. Choose the action that saves the most lives. The other sees some actions, like killing an innocent person, as always wrong, even to prevent greater harm. Though invented in philosophy, the trolley problem connects to real-life choices in medicine, war, and designing self-driving cars. It shows how our moral instincts can clash with cold calculations. Maxwell's demon, breaking the rules of physics? Imagine 2 boxes of gas connected by a tiny door. A small, clever demon controls the door, letting fast-moving particles into one box and slow ones into the other. Soon, one box heats up and the other cools down, creating order from chaos. At first glance, this seems to break the second law of thermodynamics, which says entropy or disorder must always increase. But scientists realize the demon must keep track of countless particles, and processing that information has an energy cost that restores the balance. Maxwell's demon shows us even abstract things, like information have physical consequences. It also teaches that the laws of physics hold firm, even against our cleverest thought experiments. Laplace's demon, predicting the universe. Imagine an all-knowing mind that knows the position and speed of every particle in the universe. With this knowledge, it could perfectly predict everything, from falling leaves to human choices. This was imagined by mathematician Pierre-Simon Laplace in the 19th century, based on the idea of determinism, that the present entirely determines the future. But modern science complicates this picture. Quantum mechanics introduces randomness, and chaos theory shows tiny changes can lead to huge, unpredictable effects. Even so, Laplace's demon makes us ask, if the universe really were fully determined, would free will be an illusion? Or is there still space for choice in a mostly predictable world? Newcomb's paradox, free will versus prediction. Imagine 2 boxes. Box A, transparent, always contains $1,000. Box B, opaque, may contain 1 million or nothing. A highly accurate predictor has already filled. Box B, if it predicted you'd take only box B, It put the million in. If it predicted you'd take both, box B is empty. Do you take only box B, trusting the predictor, or both boxes? It seems rational to take both. But if the predictor is almost always right, those who take only box B usually win big. This puzzle asks, are our choices truly free if someone could predict them? And can knowing you're being predicted change the outcome? It challenges what we mean by rational choice and shows how prediction and free will might be tangled together. Twin paradox. Time isn't the same for everyone. Imagine twins. One stays on Earth. The other flies on a spaceship near the speed of light. When they reunite, the traveling twin is younger. This isn't science fiction. It's a prediction of Einstein's special relativity. Time runs slower for objects moving very fast compared to those at rest. It shows time isn't absolute. It depends on speed and motion. GPS satellites even correct for these effects to stay accurate. The twin paradox makes us see time not as a fixed flow, but as something flexible, woven into the fabric of the universe. Which of these thought experiments surprised you most? Let us know, and keep exploring the strange ideas that change how we see the real world.